Hey, welcome to Klein's Geometry. Today we're going to talk about Lesson 8-4, Angles of Elevation and Depression. We're going to use them with our trig. So it's one of those things, it's a terminology thing more than anything. But when you're drawing these pictures, to use your trig ratios and find stuff, you need to know what they're talking about when they say these things. So let's just take a look at what we've got here in the picture. We have a bird, and he's flying straight ahead through the skies, and he's looking straight. So this is a nice horizontal line. We have a squirrel on a nice flat plane, and he's looking this way. Now, if the squirrel sees the bird and looks up, so he was looking horizontal, and then he tipped himself and looked up, that's an angle of elevation, because he went from horizontal to looking up. Now, if the bird, who's flying down straight across the sky, sees the squirrel and looks down at him, that's an angle of depression, because it went from straight ahead down. Okay? Now, here's the interesting thing about these angles. Because the ground and the flight of the bird are actually parallel lines, and you could think of this line between them as a transversal, the angle of depression equals the angle of elevation. Angle of depression equals, the measure of that angle equals the measure of the angle of elevation by the alternate interior angle theorem. So these have to be equal. Now, why is that good to know? Well, sometimes you might get something like, hey, this bird is actually 100 feet in the sky. He's flying at a height, an altitude of 100 feet. He looks down and he sees a squirrel. And he looked down with an angle of depression of 30 degrees. And they might say to you, in fact, they do a lot, what is the horizontal distance between the bird and the squirrel? We'll just call that D. And if you look at that right triangle right there, you say, well, I should be able to find it, but I don't have an angle. And then you say, angle of depression, 30 degrees. Alternate interior angle theorem. This is 30 degrees also. And all of a sudden, you've got a problem you can solve. Let's just quickly solve it, just see how it goes. If I think about what do I have, what do I want, and what ratio will I use, okay? Well, this side is opposite, it's right angle, my angle that I know, and this side is adjacent to the angle I know. So I have the opposite side, I want the adjacent side, and I think, so, opposite over hypotenuse, adjacent over hypotenuse, TOA, opposite over adjacent. That's what I need. The tangent, the TOA. The tangent of 30 equals the opposite side, 100, over the adjacent side, which is just going to be D. Recall, if I multiplied by D and divided by tangent of 30, these two numbers are going to trade places. So D equals 100 over the tangent of 30. Well, I come right over here and I say 100 divided by the tangent of 30. And I see that my horizontal distance along the ground is approximately equal to 173 points. And we'll just round to the hundredth place. 5 is in the thousandth, so we'll bump that up to 1 feet. And it's feet because it was feet up here. Okay? So that's how you use the angle of depression. Remember, depression, from where you're looking, you look down. Elevation, from the horizontal, you look up. And angle of depression is always congruent to angle of elevation by the alternate interior angle theorem. Let's use that idea to find out how wide the river is. Here's what we have. A hiker up here. and he's looking out over the horizon. The river is down here. And when the hiker looks down to this side of the river, he looks down 62 degrees. If he looks down to side B of the river, he only looks down 46 degrees. We want to find the river width. I'm sure all of you would agree if we knew this length from here to here and this length from here to here, we could say the width would be B minus A. Okay? So how would I find this length? Well, let's use look at this triangle right here. And this would be a leg, and this would be a leg. Oh, and also I know that that hiker, that canyon is 110 feet high. When the hiker looks down, if this angle of depression is 46, well then this angle of elevation must also be 46 degrees. So if I look at this, I think, okay, to find this length, which is adjacent to the angle, this length is the opposite leg to the angle. Think have, want, and my ratio. Well, I have the opposite leg and I want the adjacent leg. So that SOHCAHTOA gets used a lot. SOHCAHTOA, the ratio is going to be the tangent of 46 equals 110 over this length B. Swap them out, and B is going to be 110 over the tangent of 46 degrees. That would find me that length, and I never round to the end, so I'm just going to kind of put that to the side. Good to know. I'll use it there. What about if I want to just find this length, A? Well, if this angle is 62 degrees of depression, then this angle of elevation is also 62 degrees. So I can use the same reasoning and say the tangent of 62 degrees is going to be the opposite, 110, over length A, and then I will swap those out and get length A equals 110 over the tangent of 62 degrees. Now going back to my B minus A for the river width, I'm going to say the width of the river is 110 over tangent of 46 minus A, 110 over the tangent of 62 degrees, and then I just plug it into my calculator. And I'll say 110 divided by the tangent of 46 degrees, close those parentheses, minus 110 divided by the tangent of 62 degrees. Now, your calculator knows order of operations, so it's going to divide before it subtracts. And right there, there's the width of the river, 47.74 feet. That's all you need to do for that, and I think you have a problem just like that on your homework. So good luck to you, and happy calculating.